going on page 43 when we are done. We are going to talk about zeros in multiplicity. You know what zeros are. We've already found zeros. We've talked about zeros. We know what they are. But tell me, we can call them zeros. What other names do we have for them? X-intercepts, okay. X-intercepts, roots. One more, solutions, good. Whew. If I spell it right. Okay, so zeros, x-intercepts, roots, solutions, all of those are talking about the same point, or points, on the graph, right? Right there, on the x-axis. All right, so the x-intercepts of a function are also called zeros. All right, so we've used x-intercepts and we've used zeros so far. All right, we're still talking about polynomials. So a polynomial function of degree n can have at most n real zeros. So if the degree is 5, I can't have 6 real zeros. If the degree is 5, I can have at most, which implies I don't have to have 5, right? At most 5 real zeros. So some of them might be imaginary, but I'd have at most 5 real zeros. If I have an even degreed polynomial, right? 2, 4, 6, 8, 10, and so forth, it has an even number of real zeros or no real zeros. 0 is not an even number, but in this case it kind of is, it's treated like one. So if I have a 6th degree polynomial, I'm not going to have 5 real zeros. Okay, I'm going to have 6 or 4 or 2 or 0. That's the way it works. If I have an odd degree polynomial, it has an odd number of real zeros. So let's say that I have this. I don't have to have any, right? So I could have something that looks like this. Then that would be the 0, but we know this would be even for a couple of reasons. But in behavior tells us 1 for sure. And then I could have something that looks like that. That would definitely be an odd degree polynomial because I have 1 real 0 right there. Okay, all that good? All right, so now let's look at linear factors and solutions. So the solutions, so there's that word, to the equation f of x equals 0 are the zeros of the function. So that means that we get the x-intercept when y is 0. They are also called roots. So there we go. We've used all 4 of those terms. So if x equals c is a solution to the equation, then x minus c is a linear factor. Of the polynomial function. Linear because the exponent on x is 1. And linear factors can be found by factoring the polynomial. Factoring is not going away. We have to be able to factor quickly and accurately to be able to function. No pun intended. Have to factor our functions to function. All right, so let's see. It says given this, what are the linear factors? So in order to find that, I need to factor it. We always look for a GCF. GCF is x. That leaves me with x squared plus 5x minus 24. A is 1, so this makes this super easy to factor. This is x, and this is x. I need 2 numbers that multiply to give me a negative 24, so I know that the signs are opposite. They have to subtract to give me 5, so what are my numbers? 8 and 3. Which one's negative? 3. And this is 8. Okay, so there you go. Boom, factor. So my linear factors are x, x minus 3, and x plus 8. Those are my linear factors. From those linear factors, I find my zeros, right? So my zeros are, and I put them in the little set notation with the brackets. Write down your zeros there for me while I get the phone. All right, so my zeros, I should have -8, right? Then what? 0, then 3. And don't forget about this being a factor that gives you a 0. We should know that since this is cubic, the number of zeros, I'd either write 1 or I'd write 3. Sometimes we'll write an even number, and we'll talk about that in just a little bit. But all right, so we're going to find the zeros by factoring. We're going to skip number 1. We're going to jump to number 2. So I want to find all the zeros below by factoring. So that means I set this equal to 0 and I start factoring. I have a GCF of x. So we get x times 2x squared minus 5x minus 3. A is not 1, so I want to factor by grouping. So do 2 times a -3 gives me a -6. 2x squared, so I've got to split my middle term. Two numbers that multiply to give me a -6, combined to give me a -5. -6 and +1. Cannot be 2 and 3, even though 2 times 3 is 6 and 2 plus 3 is 5, because the signs have to be opposite. So it is -6 and 1. -6 and +1. So then I'm going to factor by grouping. I'm going to use brackets here. So factor out a 2x. That leaves me with x minus 3. Here I factor out a 1. Leaves me with x minus 3. So 0 is equal to x times 2x plus 1 times x minus 3. Okay. This right here, this is fully factored. Okay, fully factored. Some of you stopped too soon when you think you were fully factored and you are not. I am now fully factored. Now I can get my zeros from that. What's the smallest one we got? -1/2. Then what? 0, then 3. Those are my zeros to the function. Any questions about that? All right, number 3. Going to do the same thing. I have x to the 4th. Does that make it more difficult? No. In my opinion, it's actually easier than number 2 because a is 1 at least. So 0 equals, I just treat it like a quadratic. Since a is 1, I can jump to this, and I got x squared and x squared. This is positive, so the signs are the same. This is negative, so they're both negative. What do my numbers have to be? 4 and 1. Can I factor some more? Yes, what do I have here? Difference of squares. So this is x plus 2 times x minus 2 times x plus 1 times x minus 1. Now that's fully factored. So I have 4 zeros here. I can list out all 4 of them, totally fine. But I can also, in this case, do plus or minus 2 and plus or minus 1. Either way is perfectly fine. If we have to list a ton, we probably want to go with this version, though, just because it makes it easier to list a bunch of numbers, but 4 isn't that bad. All right, what questions you got? All right, you factor number 4. Some of you came in knowing very little about factoring, but worked your butt off to figure factoring out, and that is good. You should be able to factor this with confidence. Of course, the first thing that makes factoring difficult is if you don't know your multiplication facts. It makes it real hard. Oh, goodness gracious. once I get to this point, can I factor some more? Can I factor both of them more? Yes. So this is 3x plus 1 times 3x minus 1 times x plus 2 times x minus 2. So my zeros, plus or minus 1/3, and plus or minus 2. The concept here is zeros, not factoring, but you have to be able to factor to figure out your zeros. So, and you've got to be able to get this basic factoring down, just like you have to have basic fraction knowledge. So if you can't add 1/2 and 1/3, you're not going to be able to add the stuff that has the variables in it. If you can't factor this basic stuff, when we start factoring with trig stuff and logs and other things that don't look just like this, that's not going to make any sense to you. If this totally makes sense to you, the rest is no big deal. All right, let's see. We're going to jump to number 6. Bless you. All right, so here I have 4 terms. Does this make this more difficult than what we just did? No, in my opinion, it makes it easier because what we just had to do was split the middle term. Basically, this is already split for us, so we're just factoring by grouping. So go ahead and factor by grouping and find your zeros. Okay, so when I get to this step, I have factored it. Do we agree that I factored it? Is this fully factored? No. Could I get my zeros from the factors that I have right now accurately? I could, but I highly suggest that you don't. And for now, I want you to fully factor things. But I could set both of these equal to 0. And if I do 4x squared minus 1 equals 0, that'll give me 4x squared equals 1, so x squared equals 1/4. Oh, that's a 3. My goodness. All right, so then at this step, one of 3 things is going to happen. You're either going to do it 100% right because you totally understand what you're doing, or you're going to freak out because you don't know how to take the square root of a fraction, or you know how to take the square root of a fraction, but you forget your plus or minus. So 2 of those 3 things are bad. Knowing what to do, totally fine. But I suggest that we don't stop here, that we continue to fully factor because you need the skill of fully factoring, plus that keeps you from accidentally leaving something off. Because if I keep going and I get 2x plus 1 times 2x minus 1 times 5x minus 3, then it's just a matter of me getting my zeros from here, and that will give me plus or minus 1/2 and 3/5. Which are the 3 zeros I would expect. If you'd forgot your plus or minus, you'd only have 2, and that should make you question things. Okay? What questions you got? Okay, perfect. All right, so let's see why we're talking about zeros again. What we're going to add to this is multiplicity. So the multiplicity of a 0 is the degree of its corresponding linear factor. Let's see what that means. We're going to find the zeros of the functions below and state their multiplicities. So I need to factor this. So we've got to find the zeros. So I'm just going to start factoring. I got x times x squared plus 10x plus 25. All right, so then I have this, a is 1, so I can jump to the parentheses. X and x, this is positive, so the signs are the same. This is positive, so they're both positive. What are my 2 numbers? 5 and 5, okay? Which means I can actually write this as x times x plus 5 squared. So this is a cubic function. When I fill out my zeros, I'm only writing 2 numbers, 0 and negative 5, but this one has a multiplicity of 2. It's considered a double root. So if you were asked for the multiplicities, then we have to write them out. We have negative 5, and that's a multiplicity of 2. And then we have 0, which is a multiplicity of 1. So we don't have to write that out every single time that we list our zeros unless it does say state their multiplicities. If it says state them, we have to state them. Okay? If not, then it's good to, you have to at least pay attention to them, because otherwise we're writing 2 zeros and we know we should have an odd number. Well, this one, we don't write it twice, but it's a double root. Okay? Everybody good with that? All right, then you factor number 8, find the zeros and the multiplicities. See if you agree with me. When it says the degree, when we're looking at the degree of the linear factor, right? This has a 1 on it. That's why it's a multiplicity of 1. This is a 2. That's why it's a multiplicity of 2. These both have a 2 as an exponent. That's what makes their multiplicities 2. Okay. Now notice, I skipped a step that some of y'all might have done right here. That's fine, because these are perfect square trinomials. And if you recognize that, great. If you don't, then just factor it. It's fine. Even though I know what it is, sometimes when I'm factoring, I'm not thinking about special cases, and I end up just factoring it like this, and I'm like, oh, look, I could have done it differently. But if you can take half of this middle term and square it and get this term, take half, square it, and get this term, then it's a perfect square trinomial, and you can kind of skip that step. But some of you are not ready to skip steps, but some of you are. Some of you may have already done that, and that's good. Okay? What questions we got? All right. So let's look at this multiplicity stuff and graphing. So we're supposed to write this equation in factored form. So let's factor it. We've got f of x equals, I'll go ahead and factor out the x. That gives me x squared plus 4x plus 4. So this is this x. I can take half of this and square it and get this. So I know this is x plus 2 squared. So here is my factored form. F of x is equal to x times x plus 2 squared. So then it says to graph it. Okay, so some things I need to know to graph a polynomial. In behavior, what's this in behavior going to look like? Down, up. This is odd, right? And so it's either down, up, or up, down, but it's down, up. I need my zeros, which are going to be at -2 and 0. What happens at -2 on my graph? Bounce. Okay, so at -2, I have a bounce. We know this from last week, right? What is my y-intercept? 0. Okay, if you have an x-intercept of 0, your y-intercept is 0, 0, right? All right, so we're going to graph this. Go 1, 2, 3, 1, 2, 3. I plot -2 and 0. So I know I start down. I'm going to bounce on -2, and then I'm going to go up like this, so it'll look something like this. Ooh, that is a little sharp. Something like that. So we're going to talk through and give some proper words to some of the stuff that we did on Thursday and Friday. I like doing this after we did. I could have done that after this lesson, but I think it's better for you to have done it, and then this makes more sense. Otherwise, you're just filling in words that don't necessarily mean anything to you. So when the multiplicity, we're talking about the factors. When the multiplicity is even, okay, so like this, we do get a bounce, right? But what's our real word for bounce? Tangent. The graph is tangent to the x-axis at that 0. So that's a bounce. That's what we think about like when we're graphing it, but we need to know that that means that it's tangent, okay? Just touches it at that point. When the multiplicity is 1, okay, just plain old 1 like it was here for this 0, then the graph just passes through the x-axis at that 0. So it's boring. It just passes straight through. Then when the multiplicity is odd and greater than 1, what happens there? Point of inflection. Good. And what's our graphing word for that? Wiggle. Remember what happens there. Just a little wiggle. Okay. Everybody good with that? Questions? So when you're sketching it, you want to think about bouncing and wiggling because that helps you visually. But when we're talking algebraically, then we have to make sure we can use the real words here. All right, so let's look at number 9. Number 9 is factored for me. Great. So I need to find my zeros, least to greatest. What's the smallest one I've got? -4. What would the next one be? Okay, so I don't have there's no reason to have a plus or minus, because yes, these are double, but I still would just set this equal to 0, so to get 2x minus 3 equals 0, that'll give me 3 halves, right? And then I'd have x minus 1 equals 0, and that would give me 1. So what comes next in this order? 1, and then 3 halves, right? Not 1.5, and definitely not 1.5. All right, so then I'm just going to fill in my zeros. I've got -4, 1, and 3 halves. So then what's my multiplicity for -4? 1. So that just means all that happens is that it passes through the axis. Passes through. It's kind of boring. And then what's my multiplicity on 1? 2. So what's my real word for this? Tangent. Tangent to the axis. And then 3 halves, my multiplicity is 2. So this is also tangent. All right, questions on that? All right, then you factor number 10 and see what you can get filled out there. What's my multiplicity on -4? 2. So what's the effect? Tangent. What's the multiplicity on 0? 3. And what's this? Point of inflection. Remember, I'm okay with you abbreviating it, but make sure you add the L so I know you know it's inflection and not infection, and we're all good. Okay? Any questions at all? Awesome. So then make good use of your time and either work on the sketches from Friday or your Delta Math